Okay, so today we're gonna discuss about the reaction of metallic oxides with acids. Okay, see we have metallic oxide. I'm writing here metallic oxide or metal oxide. Metal oxide. When they react with acids, okay, they use metallic salt or metal salt and water molecule and water. Okay, so it is nothing but the salt and water type, right? Product. That means if here we have acid, that means it is acting as a base beta. So it is a kind of neutralization reaction of only. Okay. So I'm just taking one example of metal oxide. Okay. Like we have sodium oxide, Na2O. Okay. And we have taken acid, you can take H2O, H2SO4, anything. Or sorry, HCl or H2SO4, anything. So I'm taking here H2SO4. Okay. So they use sodium sulfate Na2SO4 plus that hydrogen and oxygen going to react to form water H2O like this. Easy. Okay. So now we have to describe the reaction better. So what will be the description of the reaction? When metal oxides react with what? React with what?
Acid.
Yes, acids. Use like salt of corresponding metal. Salt of corresponding means whatever the metal oxide we are going to use, that metal is going to salt. Huh? That's why salt of corresponding metal. Okay, salt of corresponding metal and water. Easy.
Sir?
Amita?
Sir, in the left-hand side, they are telling reaction with basic oxide. So metallic oxide and basic oxide are same only, sir?
Yeah, metallic oxides are only basic oxide. Beta.
Okay,
Basic
sir.
oxide. And non-metallic oxides are acidic oxide. See here, PbO, lead oxide, copper oxide, and sodium oxide. All these are metallic oxide. Na? That's all. Okay. So metallic oxides are basic in nature. Basic in nature. They are basic in nature. Okay.
Sir, does this count for every metal oxide?
Yes. It is for almost all metal oxides are like few we have like aluminum oxide Al2O3 and ZnO, zinc oxide. They are like between acidic and basic oxide. Why? Because they react with acid as well as base to form salt and water. So these two metal oxide are called as amphoteric oxide. Amphoteric oxide. So along with acid, they act as a base, and along with base, they act as acid. Okay. Hence, they are called as amphoteric. Otherwise, all other metal oxides are basic in nature. Beta. They are also basic, but with acid.
Sir, can you
But they are also acting as a amphoteric oxide. Okay, I'm writing here. Wait. Amphoteric oxide. So those metal oxides which reacts with acids as well as with base to form salt and water. Okay, those metal oxides which react with acid as well as base to form salt and water are called as amphoteric oxide. Amphoteric oxides. Example: Al2O3 aluminum oxide and ZnO zinc oxide are amphoteric in nature.
Sir,
Okay,
there are
everyone.
more oxides more than these two.
Generally, these are like they shows that nature beta. Otherwise, other metal oxides they do react differently. Okay. See, amphoteric
Sir,
oxide
only
means
two are the examples, sir. We cannot have
beta,
more. Sir, I'm
there may
asking,
be
are
yes, there may be more example, but these are the example we can like perform the experiment and it is known to us now. Okay, there may
Okay,
be many other metal oxide. Okay, but these are it is known to us now. Okay.
okay. Yes, sir.
So for action with basic oxide, so basic oxides are generally metallic oxide. So you can say, see, amphoteric means they act as an acid with base. Okay, they act as acid when they react with base, or you can say they act as a base when they react with acid. Means they shows both properties. Okay. Yeah, here
Yes,
we
sir.
have lead oxide, which is nothing but metal oxide, reacts with nitric acid, gives lead nitrate and water. So water is the common product. Okay, then copper oxide react with sulfuric acid, use copper sulfate and water. So all these are nothing but the basic oxide. When they react with acid, they give salt and water. So it is a kind of neutralization reaction. Easy.
Yes,
Yes,
sir.
sir.
Yes,
Take a
sir.
screenshot for the same and repeat it once, beta. Very important, huh? Is it or not?
Yes, sir. Yes, sir.
Yes. So the oxide, okay, and hydroxide of the metal are called as bases. So metallic oxide and metallic hydroxide, both are basic in nature. We already gone through that, right? Example of the bases like sodium hydroxide, we already gone through. Magnesium oxide, calcium oxide, copper oxide, potassium hydroxide, magnesium hydroxide, etc. are nothing but the metallic oxide and metallic hydroxide. So they are basic in nature. Some bases are water soluble when they
Sir?
dissolve in beta.
So dioxide is also come under this. Dioxide, sir. Like sulfur
What?
dioxide.
Yes, yes,
Sulfur
yes,
dioxide.
yes. Sulfur dioxide, H. SO2. No, this is the non-metallic oxide, beta. Sulfur dioxide, SO2. This is non-metallic oxide. So this is acidic in nature.
Okay, sir.
Yeah. Okay. A base that is soluble in water are called as alkalis. Okay. So we have alkali metals, right? In our modern periodic table, in first group beta, we have alkali metal. You know that, right?
Yes, sir.
Yeah. So why they are alkali? Because their oxide, sorry, hydroxide, when they dissolve in water, produces OH negative ion. So they are water soluble. That's why they are called as alkalis. Okay. For example, when sodium
have-
hydroxide,
Sir, their pH level will be more than 10 or 11, right, sir?
yeah, they are stronger. Yes.
Yes, sir.
Okay. Yeah. So for example, when sodium hydroxide is dissolved in water, it readily dissociates to produce lot of hydroxide ions. The hydroxide ions are produced. This is a characteristic property of the bases. Okay. So we have NaOH when it is dissolved in water produces Na positive and OH negative ion. Easy. So all alkalis are the bases. Yes, all alkalis are the bases that dissociate in water to produce the hydroxide ion. As the only negative ions is like metallic. Yeah, it is the only negative ion here. Okay, OH. Sodium hydroxide, potassium hydroxide, calcium hydroxide, and ammonium hydroxide are the common alkalis because when they dissolve in water, produces OH negative ion. Okay, everyone.
Yes, sir.
Okay.
Yes, sir.
Okay. So if you want to take screenshot, you can take it, everyone. Done.
Yes, sir.
Yes, sir, done, sir.
Now strong base or strong alkali. So we already gone through that. When those bases, when they dissolve in water and dissociates completely, are called as strong bases, na? Right?
Yes, sir.
Yeah. So we have already covered that. Even weak base we have covered. Those bases they do not dissociate completely when dissolved in water are called as weak base. So we have only one example, ammonium hydroxide.
Sir, why did they put a slash alkali to it, sir?
Because
is
they
not
dissolve. No, they are alkali only, but they are basic in nature. So bases are many beta, but these bases dissolve in water to form OH negative ion. That's why they are called as alkali. Okay.
Okay, sir. Yes, sir.
Will you please repeat? What are alkali and water bases?
Sir, are you asking me, sir?
Yes, yes.
Okay. Bases are those bases when they dissolve in water, they produce or dissociates in water to produce OH negative ions, whereas alkali are
Yes.
the bases which, when dissolved in water, they. So how do we give the difference between them?
Okay, see. All alkalis are the bases. Okay. But not all bases are alkalis. Like we have bases like sodium hydroxide, potassium hydroxide. Okay, see sodium hydroxide, it belongs from first group, right? So in first group we have lithium, okay, then we have sodium, then we have calcium, okay, then we have other, but these are the metal we are going to consider, okay. See, sodium have lithium have lithium hydroxide, right? LiOH. Sodium have NaOH. Calcium have CaOH. No, calcium is not found here. Potassium here, beta, potassium. It's not erasing. Yeah. Okay, so it is KOH. Okay. So see here, these are the metallic hydroxide, you can say, of lithium, sodium, and potassium. When they dissolve in water, they dissociate completely to form OH negative ion. Okay, they form OH negative ion, right? That's why they are called as alkali because they dissolve completely in water. So they dissolve completely in water. Okay, hence they are called as alkali.
Sir, if they don't dissolve completely in water, then are they not called alkalis?
Yes, they will not. Then we have like calcium, magnesium. They are alkaline earth metals, beta. Okay, they are alkaline earth metals. Means they are also basic in nature, but their basicity is less as compared to first group element.
Okay, sir. Yes, sir.
Yes. Okay.
Sir, then weak bases they only dissociate partially in water. Then why are they also known as alkali? It is written.
No, they are not called as alkali. Where it is written?
Sir, weak base slash alkali. It is written over there.
Okay. Wait, a base that dissociate in water only partially to use low concentration of the solution. Okay, are known as weak base. Means they are not going to dissociate completely. Okay, calcium hydroxide, ammonium hydroxide
Sir,
are
started
the
to
weak. They are weak alkalis, beta. They are also alkali, but they are weak alkali. Okay,
Sir,
Okay.
beta.
sir, disassociates means
To break down. See, NaOH is there.
means
NaOH.
dissolving, sir. Means
No,
dissolving.
no, no. See, we have NaOH. So they will like when dissolve in water, they breaks beta. So here NaOH bond breaks that one. Okay, and produces and attract the electron of sodium towards it. Okay, so it gives Na positive and here what is the name you had taken an example? Okay, so I hope you understood what are alkali.
Yes, sir.
Yes.
Yes, sir.
A reaction of bases or alkalis. Okay, neutralization reaction. So any doubt beta here?
No, sir. No doubt, sir.
So can you show the weak bases also? Sir,
Beta?
so can you show the weak bases? Yes.
Hmm.
Completed, sir.
Okay, any doubt beta here?